Hi guys, today I would like to discuss the concept of Ohm's law. We'll be discussing the concept of Ohm's law. It's a very basic law of electric circuits. Now, in order to understand this, we should understand what's the model of a conductor and what is happening inside the conductor. It's not the realistic thing; it's just a model. So, if I have a conductor, you know that a conductor is having a lot of free electrons. Now, what is the meaning of free electrons? See, I have seen that many students are having a confusion with electrons moving, and they sometimes say protons are moving. So you should clearly understand what is happening inside a conductor. So let's assume that this is part of a conductor. If this is part of a conductor, can you tell me what are the things inside it? There will be atoms and there will be electrons. So let us denote this as atoms. Okay, there will be atoms here. The atoms will be bounded together and they will be neutral. Now, the property of conductor is that, see, these guys are bounded together. They are bounded together. The property of conductor is that at a room temperature, the energy is sufficient so that the electrons will escape the atom. Now, when the electrons escape the atoms becomes positively charged ion. So you will be getting something like this. You have positively charged ions and electrons. Now, these electrons are known as free electrons. Why free electrons? Free electrons is because now the electron is no longer within the vicinity or control of the atom. It is free to move around inside the conductor. That is why we will say the electrons are free. What about the ions? There is a misconception that the ions will also move, but these ions are immovable. They are basically atoms itself. The atoms, when it loses one electron, they become an ion and they are fixed in the lattice. So these are immovable. So I have immovable positive ions and freely flowing electrons. Now, this is the idea of a conductor. In a conductor, you will be having fixed positive ions and free electrons. The electrons can move anywhere inside this fixed positive inside the conductor. Now, generally at room temperature, you are not giving any type of, you are not connecting a battery, you are not doing anything. You simply have a conductor here, and what do you think will happen? Is there a current generated? What is the idea? So we will not be drawing the positive ions anymore. It is understood that that is fixed inside the conductor. So we have these electrons here. These electrons are in complete random motion. Now, if you take any cross-sectional area of the conductor, the number of electrons moving towards the right side will be equal to the number of electrons moving towards the left side. In general, on an average. So I can say the net current is nothing but zero, because current is nothing but how many charges are passing through a cross-sectional area in 1 second. So I have equal amount of charges passing through the cross-sectional area in opposite directions. That is why the net current in this case is zero. So at room temperature you will not be getting any current. Now let's say I have something like this. I have this conductor here, and let's say by rubbing I introduce some positive charges here, an excess amount of positive charge. I got an excess amount of positive charge. Or this side has lost some electrons, and therefore I'll be having an uh, excess amount of electrons on the other side. So just by static friction or by friction, let's say I have introduced some excess electrons on one side. That means I have deficiency of electrons on the other side. Now in this case, what do you think will happen? So this freely flowing electrons, they will be attracted towards this positively charged ions. See, that is not the fixed positive ions inside the conductor. That just shows the deficiency of electrons. So there is a deficiency of electrons there. So what these electrons will do is, it will slowly drift towards this positively charged section. Now due to this, what will happen? There will be a momentary current. A momentary current will be there. Now, do you think this current will be there throughout the time? After 5 minutes, will it be there? No. So you can see that after sufficient electrons combine with this deficiency of electrons here, when this balance out, you can see that again the conductor becomes neutral. You have again the neutral conductor, and again the net current will be 0. So that's the idea. So once the potential difference or the charge difference uh, at both the sides of the conductor is no longer there, then I can say the net current will be equal to what? The net current will be equal to 0. Now see, my purpose is I should get a continuous flow of current. Now how do you think we can get a continuous flow of current? How to get a continuous flow? If I want to get a continuous flow, I should use something known as battery. Now the idea of battery is that it always gives a constant potential difference across its terminals. So it maintains a constant potential difference, means the charge difference across the terminals of the battery will be always same for a sufficient amount of time. So that's the idea of a battery. So if I have a battery, let's say I have battery here. So that's my battery. This battery will be having two terminals. One will be positive and one will be negative. That means I have excess amount of positive charges here, and or I can say I have a deficiency of electrons here, and I have an excess amount of electrons on this side. So this is what is known as a potential difference, or a charge difference in this case. So let's say I connect this battery with a conductor. Okay. Now if I look at the cross sectional area of the conductor, see, I will enlarge it. So this is my conductor here. If I look at this side, you can see there will be a deficiency of electrons, and on this side there is an excess of electrons, and always this difference is maintained. That's the important idea. Always this difference is maintained. When always this difference is maintained, these electrons will always be moving towards this positive charge. Now the current is not momentary. Always there will be a flow of electrons towards the positive charge. So because of that, I can say that there is a continuous flow of current in this circuit. Okay. Now, what's the direction of current? Conventionally, the direction of current is taken to be opposite to the direction of electron. So I can say that current is moving from the positive terminal to the negative terminal. There is a continuous flow of current. That's the idea. Now, Ohm's law is a law which tells you how much current passes through a conductor. How much current? If I have a situation like this, how much current passes? Let's say I have a battery. The symbol of battery is this. Now onwards I will be using this as the symbol of battery. That's my positive terminal. That's my positive and that's my negative terminal. Let's say the potential difference is 1 volt and you are connecting a conductor here. Now this conductor will be having a resistance. So throughout the conductor there is a resistance, but in our model we will just denote the complete resistance here by using a symbol R. Now you remember that the resistance is throughout the conductor. Just for the sake of drawing the diagram, we are denoting it by the symbol R and this line. Yes. The first idea is what will happen. Now I know a current will flow in this direction from positive to negative. What will happen if I introduce a battery of higher voltage? I introduce a battery of higher voltage. Let's say 10 volt. What do you think will happen? Now the potential difference or the difference in charges between these two terminals will be more. So because of that, there will be a stronger attraction of electrons, or I can say the current flow will be more in this circuit. So the first idea is current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor. That's the first idea. Now, does it depend on anything else? Yes, depends on something else. So you can see that, let's say initially I have taken the wire copper. Here also I have taken the wire copper. Using the same battery, I'm taking the same 1 volt battery, same potential difference is applied. But let me try to connect a different wire. You can connect anything, so we will try connecting an insulator. Let's say I have a plastic wire, a wire made of plastic. Do you think there will be a current? See, I am applying the same potential difference, but do you think the current will be affected? Yes. You can observe that experimentally also, you can observe that some materials conduct the electricity current easily and some materials will not conduct the current easily. This is because of the availability of the free electrons. Now in this case, the plastic, this material is not having much free electrons, so the current will be less. So it actually depends on one factor which is known as the resistance of the conductor. So if you compare the material of copper and plastic, the plastic is having more resistance. So we will deal with this later. So resistance is given by rho L by A, where L is the length of the conductor and A is the area of cross section. Now assuming length and area is same, it also depends on rho. Rho is known as resistivity, which depends on the nature of material. That means basically the resistance depends on how much of free electrons is there in the material, provided the dimensions are same. So if I take copper and plastic, the major difference is the amount of free electrons in the conductor. Copper is having a lot of free electrons, so the current will be more. Plastic is having less free electrons, so the current will be less. So in this case, you will get less current because the resistance of plastic is more than the resistance of this copper. So I understood that the current in plastic is less than the current in copper. That means current is inversely proportional to the resistance of the material. I is inversely proportional to R. If I combine this, if I combine these two ideas, I can write the Ohm's law. The Ohm's law states that my current flowing through a conductor is directly proportional to potential difference across the conductor and inversely proportional to the resistance of the conductor. Now I can remove the proportionality sign. I will assume the proportionality constant to be 1. So I got I is equal to V by R. Now this is my Ohm's law. Now here, for this condition to be valid, we should understand that the resistance and the voltage should not change. Now the resistance is actually a function of temperature. Resistance depends on temperature. So if this law has to be valid, I should assume that the temperature is constant. This law is only valid when temperature is constant. Because if the temperature changes, the resistance changes, and then the current will also change. You cannot apply this law. and you can apply Ohm's law only when the potential difference across this at one instant, the potential difference across the wire should be same. So this is basically the idea. I is equal to V by R. Now, how can I experimentally prove it? Experimental verification. For this, the idea is nothing but I should just prove that the current flowing through a conductor is directly proportional to potential difference and inversely proportional to resistance. So we need some instruments to measure the current. Current can be measured using an ammeter, and to measure voltage I can use a voltmeter. So what I can do is I can take a battery here, and I can take one conductor here. Now, so now the current flows. In the circuit, the current flows. To measure the current, I can connect an ammeter. And to measure the potential difference across the resistor, I can connect a voltmeter. I hope the ideas of ammeter and voltmeter is known to you all. So I have ammeter and I have voltmeter. I will get a current reading and I can get a voltage reading. And if I already know the value of the resistance, I can just see whether I is equal to V by R. Now the problem is here I will be getting just one value. I want to know whether this is true for a range of values. Now in this particular case, I will be getting one I value, I will be getting one V value, and I already know R. And I can verify the Ohm's law in this case. Sorry. But what to do if I have to verify the Ohm's law for a range of current values? Now for that purpose, I need to get a range of current. So in this case, the battery is V and it is giving out a constant current I based on the resistance R. Now if I want to get different currents, what I can do is I have to introduce one more thing in the circuit, which is known as a rheostat. So I have resistance here, and then I have a rheostat here. Now the idea of rheostat is that it's a variable resistance. Rheostat is nothing but a variable resistance. Variable resistance means I can introduce different amount of resistance in the circuit. So that means if I increase the resistance, the total resistance in the circuit increases. If the total resistance in the circuit increases, then the current will decrease. And if I decrease the resistance of the rheostat, the total resistance will decrease, and then the current will increase. So I will get a varying current by adjusting the value of the rheostat. Now the same procedures as before. I have A here and I have V over here. I can make a column of V and A, or V and I. Sorry. I can make a column of V and I here. And let's say for resistance, and I can make one more column for rheostat values. And I can try out different values of rheostat. Let's say when rheostat is 1 ohm, 2 ohm, 3 ohm, I can calculate what's the voltage across the resistance and what's the current flowing through the resistance. And if you measure this, you can see that always this obeys the Ohm's law. If resistance is already known, if I multiply V is equal to IR, if I multiply I into R, I will be getting the V. You can prove it graphically also. What you can do is you can plot a graph of I versus V. I versus V graph you can plot. You will be getting a straight line. The reason you are getting a straight line is because we have the relation I is equal to V by R. That means I is proportional to V and the proportionality constant is 1 by R. This is just like the straight line equation, y is equal to mx, where m is the slope. So in this case, the slope is given by 1 by resistance. So what you can do is you can plot the graph of I versus V and you can find the slope. Slope is nothing but tan theta, that is equal to delta y by delta x. So if you find the slope, you can find it as 1 by resistance. So experimentally also this law can be proved properly. So that's the complete idea of Ohm's law. So we discussed what's the basic idea of Ohm's law and how is it working. So basically, in one word, you can say that Ohm's law tells about the current flowing through a conductor or current flowing through a resistance. So the law is this: the current flowing through a resistance is equal to the potential difference across the resistor divided by the value of its resistance. It's as simple as that. It's very easy. So whenever you want to apply the Ohm's law, you take a conductor, identify what's the potential across the conductor, potential difference across the conductor, identify what's the current flowing through the conductor, then it satisfies the relation I is equal to V by R. That's a complete idea, and this is a short video session on Ohm's law. We will come back with more topics. Yeah, thank you.